do that. Hi, everyone. We have a webinar today about optimizing flow using a traffic metaphor. I'm very excited to be doing that, and thanks for the opportunity. My name is Vinaya. I've been in the software industry for a while now, and part of it has been in delivery roles and in development, and part of it, the recent 7 years, have been in coaching. I have experience in TOC, Kanban, Scrum, Scrumban, Safe, DAD. So, a range of experience, a bit of lean, a bit of agile. So that is where I am. I love Kanban. That is what this indicator is. There's some social media details on here, and feel free to connect with me in LinkedIn. I'd love to be connected with many of you. So let's start. Today, we're going to talk about two very important ideas, and we're going to try and combine the two to see what we can learn about both of these ideas. So one of the ideas is the system metaphor, which is a very strong theme in extreme programming. So we're going to look at that. It has been popularized a lot by XP, and it is something that we'll use today. We'll use it in a very lightweight manner, but I'm sure we'll find ways for ourselves to go and extend it into architecture, design, and similar things. And the second important concept that we'll speak about today is how to improve flow, how to optimize the flow of work in your software system. And I'll try and use the system metaphor as a vehicle through which we'll convey the ideas related to flow optimization. So this is what I intend to do in the session today. Feel free to ask me questions, but in the interest of time, if we need to park certain discussions, we'll do that. And feel free to chat with me later, or however you can get in touch with me. I'll be happy to discuss this. Also, I'm new to Zoom, so if I'm doing something odd, then let me know. I'm sure Shrikant will do that, but just for all of you to know. Okay, so let's start with what are metaphors, right? So if you think back to English grammar from school, we have figures of speech, and metaphors are a kind of figure of speech which indicates some kind of similarity between two different systems, right? So it's like saying, it's like a stand-in for something else that you're trying to explain. And we all use metaphors all the time. It is really a part of our language. Sometimes we don't even realize all the metaphors that we're using. But let's have a look at some of the common metaphors that we use, right? So let's say I'm on cloud 9. I'm not really on cloud 9. Similarly, if I say I'm down in the dumps, we know that I'm not really down in the dumps. So, but still, I don't think there is any confusion whatsoever when you go and tell somebody I'm on cloud 9, that you're actually delighted about something, you're feeling really good about yourself. Or when you go and say, oh, I'm down in the dumps, there is no doubt, there is no misunderstanding about what you're saying. People realize that you're feeling low and things are not going so well. Maybe you're having a bad day, whatever, right? So what is it about the metaphors that really helps us convey the idea without really talking about the idea directly? The power of the metaphor comes from the fact that the two people conversing, or the people having the conversation or the communication, have a shared frame of reference. They have a shared vocabulary that's developed over time. And that's why it promotes understanding. It really promotes teaching. It promotes sharing of ideas. So that is the real power of the metaphor. It allows us to simplify ideas. It allows us to refer to a common frame of reference, and it allows us to use commonly understood vocabulary that is shared between the group, right? So that is what metaphors are. Let's look at metaphors and their place in extreme programming. So metaphors are one of the core practices that is promoted in extreme programming. And in XP, the metaphor is used for various things. It is based on this idea that every programmer who's coding has a theory of the business problem that he's trying to solve, or he has a theory about the program that he's writing. And metaphors are meant to sort of complement this theory building of software and help capture it, help communicate it, help expand it, help enhance it. Right? So let's think about what it could mean. So metaphors are meant to be used, if somebody is following XP, are meant to be used for architecture, for design decisions, for onboarding new members quickly, because you're talking in a simpler language, something that even a new person new to your system, new to your program, can really understand quickly. It is meant to promote understanding in general. And it is something that is meant to be referred to frequently. In team meetings, it's supposed to be put up as a big visual information radiator that people can refer to time and again. It should influence design decisions. If you're enhancing the architecture, you should be able to look at the metaphor diagram that you have and see what you need to change. It should find way into class names, method names, descriptions. It should find its way into documentation. Let's assume that one programming team built a system metaphor and then programmed according to that system metaphor. And one fine day, all of them leave the company, and there's a new team which is expected to maintain this. If they are able to look at the metaphor and understand it easily, then maintenance of software developed by somebody else also becomes a simpler task to grapple. So this is the real power of the metaphor. Over time, XP proponents are talking less and less about it. I think it's because it's actually a very evolved idea. It's very difficult to follow. And I don't think it's used in practice in too many places. And that's why it's spoken about a lot less. But it's a powerful idea. It is something that can be tried. So let's maybe spend a little more time on it. So let's think of an example from the software world. So something that I thought of was that, let's say I have multiple modules in my software which need to communicate with each other. And my architect is trying to build some kind of communication bus or a transaction broker that can carry messages between these many modules, right? So one of the metaphors that I could think of, which I think would be a good fit for something like this, would be the elevator system. So let's say that we go with this metaphor. So we can start thinking about things like, okay, so for an elevator, we usually press a button and we indicate which direction we want to go in. Accordingly, one of the elevator carriages will come to us and will carry us to where we want to go to. So an extension of this to the software world could be that the bus is something that responds in demand to a message that needs to be sent, right? So it is an on-demand system. It is not something that is always on or always pulling, but it is something that can be called when you actually need it. Similarly, an elevator generally has a capacity limitation, can't carry more than, let's say, 15 people at a time. Could we extend this to our transaction or message system to say that our message cannot be bigger than a certain size, because then it would probably break the way our system works. To extend it a little further, it could be like, for example, if our elevator breaks down for whatever reason, we are still intact, we are still safe. So there is some kind of fail-safe mechanism built in over there. So could we extend it to our transaction broker message bus system to say that even if something crashes, the message still needs to be kept intact, that is something that we need to build around, that is something we need to design for, right? So this is the kind of system metaphor that may help us with architecture decisions, with design decisions, something that's easy to communicate to people, not only to other programmers, but also to people from business, people from sales, marketing, other places, right? So this I could think of. I'm sure you can think of several others. Maybe some of you are actively using system metaphors in your systems. So this is what the metaphor is. But what we're going to talk about today is more about flow optimization. It was important for us to be on the same page about what metaphors are. Like I should have a Ferrari, somebody should give me
And
a
might
Ferrari.
be flight by using your own chopper.
Okay. I wish. Okay. What else?
Can you get yourself build a faster road or something like that?
Mm-hmm. Okay. Last idea, anybody?
Work from home, don't travel.
Wonderful. You need to talk to my manager, whoever said that. Okay,
Surely,
wonderful.
once I got a thanks.
Okay. Thank you, guys. So that sounds good. And if any of you choose to run such a workshop with a lot of people, you get similar ideas. You get many more because one, this is a very easy problem to relate to. So you generally get similar ideas. Sometimes you get more. For example, recently people have started talking about Hyperloop since Elon Musk, started talking about it. So such ideas do come up, and these are great ideas for us to. We'll see how we can connect this back to the software world and how we can try and explain the principles of product development flow using some of these ideas. So what I did was, in order to make the webinar a little easier, I just picked some of the ideas that I commonly get in my workshops, and that's what's on the next slide. And I'll make an attempt to connect it back to the software world. And you feel free to pitch in, and if there are more interpretations that you can make, then feel free to share those with me. So some of the common ones that I get, which I also heard today, is better infrastructure, right? Faster roads, smoother roads. So this is something that, of course, will make my commute a lot easier. So if my roads don't have potholes, and if they are broader, and if they are laid out really well, it makes my life easier. I can go faster, and it makes my commute also a little more smooth. What it may, a parallel for this in the software world could be, again, really what's written over here, it's infrastructure. So basically, is it easy for me do I have great machines? Do my developers have good machines to code on? Do they have good IDEs to work on? Is building their software easy? Is it easy to deploy to a test environment? Is it easy to get feedback? So everything that sort of lies in the background, the infrastructure of my software setup, is it fast? Is it an enabler? Is it something that's proving to be an impediment instead? Is something that I could look at. And if this is something that I can try and improve bit by bit over time, then it is something that can help improve the flow of work in my system. So a lot of the agile engineering practices around continuous integration, etc., address a lot of this, but it's not limited to continuous integration. It's also whether my developers have the right environments to work in, whether there are too many approvals that are needed. So this is the kind of infrastructure that possibly could be a parallel for having better roadways or better roads or faster roads for us in the traffic metaphor. Right? Similarly, we heard about batch size. Somebody suggested a cycle, but a cycle could possibly be slower for me. And if I want to get from point A to point B really fast, I understand the value of a smaller vehicle, right? So a smaller vehicle is more nimble. I can, I need less space to navigate. I see space between two cars and I can take a call to sort of use that space and go ahead. So trade-offs are easier. I have more options, more possibilities. In general, I'm a little more zippy if I'm in a smaller vehicle, right? Of course, this is something that may be offset by the cost of going as an individual on a smaller vehicle versus using public transport, which may prove to be cheaper. But if I'm looking to speed up, then the smaller the vehicle, the easier it is probably for me to get from one point to another faster. So a parallel for it in the software world would be the batch size. It's impossible, I think, to talk about optimizing flow without talking about batch sizes. So reducing your batch size, seeing how to make it, smaller. It could be by better backlog refinement. It could be by, making things lighter in the system. So batch size is something that will generally enable us to go faster. The transaction costs versus the holding costs, this is something that we'll always have to balance. But the pursuit of agility would generally push us towards having smaller stories, smaller features, smaller backlog items, smaller work items. It gives us not only speed, it also gives us possibilities. So if I have a big user story and I'm doing Scrum and I need to either get it into the sprint or get it out, it's a tougher decision to make than if I have a lot of small user stories. It's easier for me to make certain trade-offs if I'm working with smaller batch sizes. So that is something that could be a connection that you could make. A lot of you suggested either going through routes which are less crowded or using an off-peak time for my commute, which basically means that I get out of my house at a time when there are fewer vehicles, or I choose a road where there are fewer vehicles. So it basically gives me a chance to go faster and reach my destination faster. So the interpretation in the software world for this would typically be to say that have lower work in progress, have fewer things going on at the same time, which basically improves our focus, it reduces the queue lengths, it helps us get to done faster. So that is the whole idea that could be a parallel of off-peak or, lighter roads that we can use. For example, if there is a whole 100 people who want to go from the same place to the other place, and we all start at 7 o'clock in the morning, then we're all going to get stuck eventually. We're all going to be slower. Instead, if we're able to stagger the times at which we all start, each of us can have a faster commute. Each of us can have a shorter cycle time for the time that we are spending on the road. So this could be a connection that we could make back to the software world. Feedback loops. So I got suggestions about certain programs that we could use, traffic monitoring apps, etc. We have Google Maps, which gives us an idea about where there is traffic congestion and where there isn't. So if we can have live systems telling us how the road ahead is going to look like, then I am actually preserving some of my options and I can make certain decisions really late in the game. I get to a fork in the road, I see that this is congested and I have an alternate route. I have the option to take that. But for that, I need, really strong feedback loops. It has to be very quick. It has to be current. It has to be very visible. So, coming back to the software world, we're talking about BVIRs, big visual information radiators, tight feedback loops, early feedback loops, live system monitoring, feedback from operators, feedback from real users, So the area of A/B testing, all of this could sort of come under the feedback loops. So this is, again, an idea that can be really expanded. So this is something that we could really dig our teeth into and expand it quite a bit and promote the inspect and adapt kind of approach to software development. Something that I didn't hear today, but I generally get this: if I had no traffic lights and I could just pass through, it would be easier. So roundabouts are a good alternative to traffic lights, which basically mean that everybody, I don't need a central traffic light or a central traffic policeman sort of directing traffic and managing it for us. We do it for ourselves. Roundabout, there are certain policies that we follow, right? If somebody's on the roundabout, they get preference over somebody who's entering the roundabout. Now, this works only if everybody follows the rules of the roundabout, which is not very common where I drive. So, self-organization. Sunil, you want to say something? Sunil, can you be on mute?
Yeah, I'm closing. Yeah.
Okay, thank you. Okay, so the roundabouts work only if there is some discipline in the people who are using the roundabouts, and they all have a shared understanding of the policies about using the roundabouts. So the parallel for this in our software development environment is self-organizing teams, right? Teams which don't need to be directed externally, which don't need to be managed constantly, but they have a set of rules by which they live. They have a set of shared values by which they live, and they are self-organized. They all abide by certain ways of working agreements, etc. So the self-organization is also a trade-off between, do we have the discipline to be self-organized? Have we really reached a certain team identity and a team dynamic that allows us to be self-organized? Versus do we need somebody to be directing us from outside? So self-organization can sort of regress and it can get chaotic. But by promoting better discipline, promoting better team bonding, by promoting working agreements and the like, self-organization can help us be faster as versus being externally directed and managed, right? So this is it's a very strong theme, especially in Scrum. So this is something that could be promoted using this analogy. And the last one I have over here is the disruptive ideas that we get. So if somebody said chopper, if I could have my own chopper, I leave from my terrace, I land on the office terrace. Wonderful. So these are ideas. So always leave space for people to go a little wild and come up with their own ideas for improving the flow in the system. What we've read about from these all the great literature that exists, etc., can still be trumped by somebody who has a wonderful, innovative, disruptive idea. And we must leave some room in our workshops and our trainings and our coaching for those ideas to come up as well. So if nobody comes up with the innovative ideas, remind them to think wild and think about whatever they can. And this is something that we need to extend to our software development as well. Leave space for people to innovate, to think, to come up with wonderful ideas, because they do have wonderful ideas. So, and that could lead to flow optimization as well. So there could be ideas that are untapped, that are things that we are not aware of, and we'll get it from the ground, which is the best way to get the ideas. So one card I would always leave, or one spot I would always leave empty for people to think about anything that they're able to come up with. So these are some of the popular ones that I've tackled over here. There are, of course, a lot more. For example, getting rid of speed bumps, or constructing an overbridge for the pedestrians for their crossing, or something else. So there are several ideas that come up. So the important part of, if you plan to use this as a workshop, is to be able to make the connection back to the software world and make it explicitly. You don't have to be the one to do it, but to get that connection surfaced is something that makes the workshop effective. Otherwise, it stays as a nice workshop, it stays as a nice metaphor, but people don't really take anything back to their workplace. So this is really the main slide that I have. So I would say that a skillful use of relevant metaphors, in my experience, has helped promote the understanding of the principles of flow. Many of the ideas that I mentioned, by the way, I need to say this, are from the book Principles of Product Development Flow by Donald Reinertsen. Many of the ideas are from Kanban and TOC as well. I had blogged about this sometime in the past. Over there, I explored a lot more ideas from the metaphor. So feel free to, use those if you find them appealing. Feel free to run these workshops if you find that it will be useful. And also, I'm happy to chat more about the metaphor about flow optimization both. I'm nearing the end of my talk. And if there are any questions, I'm happy to take them at this point of time. Or any feedback is also welcome. Any questions? Okay. Shrikant, would it be okay for me to end the webinar at this point of time? I see that there are still a few minutes left.
I think you may want to see if there is anything more to add, or if there is any more questions. Otherwise, I personally found it as a very interesting concepts which we can apply in our coaching. And I'm just wondering if there is any question from anybody. Otherwise, we would like to end this webinar.
Hey guys, hey, it's Ashish here. I just joined because I was totally forget that we have webinar at 9 o'clock. So like we are you are going to as a publish the it's recording only, right, on YouTube. Am I right?
Yes, definitely.
Okay. No issue.
Okay. Any other questions or any other ideas or metaphors that others use, which you want to share with the group?
Actually, most of the times we have used the traffic flow only for basically explaining Kanban. But I think getting into details of it and how to solve the flow of the traffic, that is much more interesting, because that's where, we understand that there is a flow problem, but how to resolve that using many different techniques becomes a relevant question. And at least this webinar helps to give those ideas on the ground. So that is really, really good, actually.
Great.
So, Vinay, one thing just an example, I generally like to use construction example a lot when I talk about agile. Interesting stuff for sure. What you discussed, right. This potentially can, be a workshop in itself, where you take each item the way you did it, and of course we can even go further. So thanks a lot.
Thank you, Satar. Okay, so metaphors be with you. May the force be with you, all of you. Thanks a lot for listening. And if you have any other feedback, feel free to, chat with me or message me. Any feedback is good. Thanks a lot. And thanks, Shrikant, Sudhab. You guys are doing a very good job of organizing these webinars. So that's really nice.
Thank you, Vinaya. Thanks a lot.
Thank you.
Thanks, Brad.
Thanks. Bye.